Okay, we're going to talk about systems of equations, and what we're going to do is we're going to start with a definition, which is a set of two or more equations. A solution to a system of equations is a point in the xy coordinate form where the graphs of the equations intersect, because we know that, for example, with linear equations, they are represented by straight lines. And those straight lines, if we have multiple lines where they intersect, will be the solution. Now this all seems very abstract, so I have a specific example here that I'm going to go through, and that is, what if we have two rental car companies? Rental car 1 charges $12 per day, plus they have to pay out 10 cents a mile, or excuse me, 15 cents a mile. And that will be how much they're going to charge you. Whereas the other company is $15 a day, but only 10 cents per mile, and that is equal to the cost that they're going to charge. So, these are our basic equations. This could be translated, we could change the c to a y, and have y is equal to 0.15x plus 12. There's the y-intercept, x is our miles, and y is our charge. So these equations, if I write them in this format, might make a little more sense. Whoops. Okay, let's change that here to 10m plus 15. So, I've gone ahead and I've calculated some points. So our x points are our miles, so I put in x is 0, I get y is 12. If x is 10, y is 13.5, and so forth. Now I created these points and then graphed these onto a grid so that you can see rental car 1, which is right here in blue. Here is the graph showing as you increase in miles how much it's going to cost. And here's rental car 2. And at some point, these two lines intersect. And where these two lines intersect is at 60 miles, which means that it costs $21 from either company if you go 60 miles. So this is a visual representation that I can see rental car 2 is more expensive as long as I'm traveling below 60 miles. Rental car 1 would be least expensive, but the more miles I drive, I can see that the pattern is rental car 2 will be less. So this intersecting point in this specific example represents when, or what value, what point value, do both of these equations come out to be the same value. So hopefully this will give you a better idea when you're solving systems of equations why and what they're for, and one example of what it matters when they intersect.